Hello students, welcome to lesson number 5 on circle theorem. The last time we met, we looked at theorem 3 and then we saw that in that theorem, when a chord AB forms an angle at the circumference and the same chord AB forms an angle at this side of the circumference, then the angle here and the angle here are the same. So we wrote down the statement as angles formed by a chord at the circumference on the same segment are equal. Angles formed by a chord at the circumference on the same segment are equal. Good. So that is what we looked at the last time we met. Now today we are going to look at the fourth theorem. We are going to look at the fourth theorem, and that is for lesson 5. So let's move on to the fourth theorem. Good. So theorem 4. Now theorem 4 is about what we call a tangent and then a chord. So the theorem 4 is about the relationship between a tangent and a chord. A tangent and a chord. Now what is a tangent? Now tangent is basically a line that touches the circumference at one point. So a line that touches the circumference of a circle at one point is called a tangent. So line ABC is a tangent. This line is a tangent. It touches the circle at one point. That is point B. Good. Now the fourth theorem says that if there is an angle formed between this tangent, that is tangent BC, and then chord BD, if there is an angle formed between them, okay, this angle, the theorem is saying that this angle formed between this chord BD and then the tangent BC should be the same as the angle that this chord BD will form at this side of the circumference. This angle. So I'm taking it again. The theorem says that the angle formed between a tangent, so in our case is BC, and a chord, in our case is BD, which is this angle. So the angle formed between this tangent and this chord is the same as the angle that this chord BD will form at the circumference. I hope you get it. So if this place is X and this place is Y, the theorem is saying that angle Y is the same as angle X. So X equals what? Y. X equals Y. So in the same vein, when you look at this tangent, tangent AB, yes, and then chord BE. Now the theorem is saying that the angle formed between this chord and this tangent, that is this angle, okay, this angle is the same as the angle that this chord BE will form at this side of the circumference. Okay, so if this place is P, then this place is Q, then it means that P is equal to Q. Okay, so basically this is theorem 4. Angle formed between a tangent and a chord is the same as the angle that the chord forms at the circumference. I hope you get it. Good. So now that we've seen the relationship, let's take a question and then apply the theorem on. Let's take a question. Good. So this is example 1 under theorem 4. So the question is, in the diagram below, O is the center of the circle. Find angle PQR. In the diagram below, O is the center of the circle. Find angle PQR. So you try your hands on this one. Then when you are done, I will come in and then we see whether your answers are correct. So I'm giving you 2 minutes to solve this question. Okay, so let's look at the solution to the question. So the question says, in the diagram below, O is the center of the circle. Find angle PQR. So our aim is to find angle PQR. So it means this angle, the angle here. So the question says we should find the angle here. So now looking at the diagram, the only way we can find this angle, okay, is when we know this angle. Because when we know the angle at T, using the theorem that we just learned, the angle formed between chord PQ and then, tangent PQ and then chord QR, okay? The angle formed between chord QR and then tangent PQ, okay, which is this angle, should be the same as the angle that this chord QR will form at the circumference. So the chord QR is forming an angle at T, okay? So it means that this angle T and then angle at Q are the same. So to solve the question, we need to find the angle T. Are you okay? Good. And to get angle T, let's look at TRQ, okay? TRQ is a triangle. So per the plane geometry 1, the sum of interior angles of a triangle add up to what? 180. So it means that when we add angle at T to this 50 to this 75 and we equate it to 180, we'll be able to find the angle at T. And from the fourth term, the angle at T is the same as the angle at Q, which we're asked to find. So let's look at the solution. So solution. So in the diagram, angle QTR plus angle TRQ plus angle TQR should be equal to 180 degrees. Okay, so angle QTR plus angle TRQ plus angle TRQR should be equal to 180 degrees. So let's see the substitute. So angle QTR is what we don't know, this angle. And then angle TRQ is 75, angle TQR is 50. Okay. So let's see. So TQR is 50 degrees. So 50 degrees. And this one is 75 degrees. Then angle QTR. So this one will give us 180 degrees. So now simplifying, we are going to have angle QTR okay, equals 180 degrees minus, this one will give us 75 plus 50 will give us 125 degrees. So finally, QTR will be equal to, so 180 minus 125 will give us 5 degrees. So we are going to get 55 degrees. 55 degrees. So it means that angle QTR is 55 degrees. But in the diagram, let's go back. In the diagram, per the theorem, angle PQR, okay, that is this angle, is the same as angle QTR. Okay, so let's quote that relation down. That angle PQR is equal to angle QTR. Okay, so then it means that angle PQR is equal to 55 degrees. Okay, good. So I hope this is what you had. So students, we'll end here with lesson 5. So we looked at lesson 5 and we saw that it's a relationship between a tangent and a chord. We have solved one example and we'll continue the next time. So the next time we meet, I will take your solution to the assignment that I'll be giving you today. So let's look at the assignment. So this is the assignment. So try your hands on this one. The next time that we'll meet, I will take your solutions. So stay safe, revise, read ahead. Thank you. Bye.